All right, so today we're going to look at how graphs are going to be done in Science 10, right? The good news is that you're not going to have to do them by hand because, well, doing graphs by hand sucks. It takes a long time, it's not very accurate, and, well, it's like Stone Age, okay? We have the ability to do graphs much more efficiently, have them be more accurate using spreadsheets and things like that. So that's the way that we're going to do it. We're going to use Google Sheets to build graphs. How many people have ever built a graph with Google Sheets? Yeah, so for most of you, this will be new. It's quite easy. Okay, it really is quite easy. So we'll walk through that today. Everybody have a Chromebook and kind of walk through that. But first, we got to go over the basics of graphing before we can talk about that. Okay, so some basics of graphing, and you have the notes there in front of you. I'm just going to use this graph as an example. Okay, but a couple of things about graphing is, first off, a graph has to have certain parts. Okay, in order for it to communicate data effectively, it needs to have certain parts. And the first and most important thing it has to have is a title, which this graph doesn't have. So it's a really bad example of a good graph because it's lacking a title. Okay, so this graph should have a title that describes what's on it. And that title shouldn't just be temperature versus rate of photosynthesis. It should really be something like a bit more detailed that actually also describes the experiment. Okay, so you could have, something like, okay, something like that, graph of photosynthesis and temperature experiment. Okay, that says I was doing this experiment, I was comparing these two things, this is the data I got, something like that. All right, so first off, all graphs have to have a descriptive title. The second thing graphs have to have are labeled axes. Okay, so there's always an x-axis, that's the horizontal one. Okay, so right here, this is the x-axis, and a vertical axis, or the y-axis. Right, all graphs have to have those. And again, in order for the graph to communicate data effectively, I have to label those axes so that I know what's on that axis. All right, so they've done that here. Okay, the x-axis is temperature in degrees Celsius. So not only is it telling me what it is, it's also telling me the unit it's measured in. Same on the y-axis. We're talking about the rate of photosynthesis. Okay, they don't really have any units there because that's a hard thing to actually have units for. All right, but it would probably be in like milligrams of oxygen per hour or something like that. Okay. All right, so this is our graph thus far. We have labeled axes, we have a title. Okay, the axis also has to have a scale. The scale has to be even. That is, every line represents the same amount of stuff. Okay, in this one you can see that every line on the x-axis is worth how much? How much? 5. Every line's worth 5. Doesn't mean I have to put a number on each one. In fact, it gets kind of busy and crowded looking if I do that. Okay, so they've only done every 10, but obviously every line is worth 5. You have to pick a scale that kind of makes sense. Now, we don't even end up picking scales anymore because the spreadsheet program will pick a scale for us and plot the graph anyway. Okay, so same thing on the y-axis. We can see that each line on the y-axis is worth, I think it'd be 50 milligrams per hour. Okay, something like that. So we've got an even scale all the way along. Right? Both scales start at 0. Your graph doesn't have to do that. Okay, a graph doesn't have to start at 0. It depends on what your data looks like. Okay, but it does, of course, make it a lot easier to do your calculations and stuff if your graph starts at 0. Okay, everybody with me so far? Yes? All right. Now, when you have a graph of data like this, okay, we can see that on this graph that as temperature increased, what happened to the rate of photosynthesis? It got higher until what? Right, until about 30 degrees Celsius, and then all of a sudden, the rate of photosynthesis just plummets. All right, so this is telling us that, yes, in general, the rate of photosynthesis goes up with temperature, but there's a kind of a tipping point, right? And there is a temperature at which plants are going to shut down because they're going to lose too much moisture, okay, to carry out photosynthesis, or maybe there's some other factors that go along with temperature that they don't like, and so they shut down, okay, close their stomates, whatever, and stop carrying out photosynthesis. Okay, this graph very effectively demonstrates that, and that's the purpose of a graph, is to kind of at a glance give you a visual representation of the data. Okay, so that I don't have to read through a bunch of numbers and kind of come up with that relationship on my own. This gives me a snapshot of what was going on in that experiment. Everybody all right with that? Okay, so that's what we want to do with a graph. We want to make it communicate everything effectively and give everyone a snapshot of what's going on. All right, so we're going to walk through now how to build the graph in Google Sheets. Okay. Okay, so to start out with, we want to have Chrome open, obviously, and we need to be in Google Sheets. So if you click up here on the Google Apps, okay, so if you're on the Google homepage, click on the Apps, okay, Google Sheets is the green one, and we want to open that up. All right, so we're just gonna create a new one, so just click on this one here that says blank, start a new spreadsheet. All right, we're just gonna click on that, and it'll give us this. Okay, it looks a lot like Excel if you've ever used Excel. Okay. All right, so what we want to do is we want to put in the data that we want to graph. When you're making a graph in Google Sheets, your first column, so in this case it'll be column A, is what's going to go on the x-axis. Whatever you want to have on the y goes in the rest of the columns. Okay, if you're only graphing one, let's say one series, then it would just be A and B. But if I'm, let's say, doing a graph of a bunch of different people running a race, then I would have, 4 different lines, let's say, on the same graph. I'm graphing the same thing about 4 people. I can put them all on the same graph, and it can do that. We'll look at how to do that later. For now, we just want to do a basic graph. Okay, so we're going to do a basic graph of this data here. Okay, so I'm just going to scroll this over so I can see my data and type it into the sheet at the same time. You guys can see the data now, so you don't have to do what I've done. All right, here's the thing though. If we want the graph to have the labels on the axis, I need to put in what's going on the x-axis first. So my first box is going to have in it what's on the x-axis. So what's on the x-axis for this one, right, is going to be the diameter. Right? Diameter is going to be my manipulated variable, and the circumference will respond. If I make the diameter of a circle bigger, the circumference gets bigger. Agreed? Okay, so I'm going to write in here diameter, and I'm going to put what units it's in, centimeters. Okay, and then I'm just going to enter the diameter numbers down below. All right, so first one is 1.8. Notice I'm not putting centimeters in every box. I put it in the top box. That's the only place I want to put it. If I put letters and numbers in a box together, Google Sheets gets very confused. Okay, and then it just has like a little hissy fit and then it doesn't work. All right, so we'll just keep adding in the numbers here. Whoop, second one was 2.8, then 3.2, and then 4.4, and then 6.6, and then 7.4. And then I want to do the same thing in column B. That's where I want to put circumference. And I also want that to be in centimeters. Okay, and I'm going to put those numbers in. So 5.6, 8.9, 10.2, 13.8, 20.6, and 23.1. Now, our next step is we want to actually build the graph. Okay, so what we need to do is put our pointer up in the very first box, click and drag until we've highlighted all of the data we want to graph, which in this case is all of the data. Okay. Once I've got it highlighted, then I'm going to go up to Insert. And when I click on that, it's going to give me a whole bunch of options. Okay, I want to go down here to Chart. Okay, so it's about halfway down. Click on that, and then it's going to give you some options. It never picks the right kind. Okay, just so you know. Now, they've got this new chart editor, which isn't great. So I always click down here on use old chart editor because the old one is a little more intuitive. Okay, so I'm just going to click on use old chart editor. So this comes up. Okay, so I want to click over here on chart types first because I don't want a bar graph. Okay, this is not something I want a bar graph for. So I go to chart types, and you can see here that it's clicked use row 1 as headers. That's good because that means it's going to label my axes with row 1, and that's what I want. I'm going to scroll down here until I see scatter. Okay, so I'm on chart types. I've scrolled about halfway down to here where it says scatter. I'm going to click on that, and it's going to change the kind of graph that it's built. Right? Now it's showing that these points all go in a line. Okay? That is, as I change the diameter, the circumference goes up by essentially a similar factor. Okay, so I've got that. Okay, I still don't have kind of all my information on this chart, so I'm going to go up here to customization. Okay, now that it's picked the right chart type, so I'll go to customization. And this is where I can put in all my information. All right, so right now it says the title is diameter and circumference, which isn't like a great title. I'm going to call it my circle graph. Okay, and then I might write diameter versus circumference. Okay, and if I click away from that, you'll see that it'll update the title up here. So if I click anywhere else, it changes it. Okay. All right, then I'm going to go down here where it says legend. Okay, legend's on the right. That's fine. I don't really need to do anything with the legend. It can kind of stay the way it is. Okay, if I scroll down a little bit further, you'll see axis in red here. Am I going too fast? Okay, where do I need to go back to? Chart types? Okay. All right, so what I did is I scrolled down here and I picked scatter plot. Okay, so I'm on chart types and I'm grabbing the scroll bar, going down here to scatter. Okay, I want a scatter plot. So I click on that, it gives me this type of graph. Okay, did you click use old chart editor? You're in this one. Yeah, it's at the bottom right corner. It says use old chart editor. Okay. Okay, then back to customization here. All right, so I've already changed the title. Okay, that goes right here. And then I'm down here where I can put in labels for each axis. Okay, so I'm on axis, and right now it's the horizontal or x-axis. So what title do I want? Well, diameter is there. So I'm going to write that it's diameter in centimeters. Okay, and if I click away from that, you can see that it adds it in down here. So I've labeled my x-axis with units. And then I'm going to do the same thing for the y-axis by clicking up here where it says horizontal. If I click on that, it allows me to change to the left vertical. All right, so I click on left vertical and I type in what I want that axis to be, and it's circumference. And that's also in centimeters. All right, if I click away from that, you can see that it puts it in there as well. All right, so now I have a properly formatted graph. Okay, I've got the points on there, I've got labeled axes, I've got a title. Okay, it's starting to take shape. There's a couple more things I need to do now. Okay, if I scroll down a little bit further, it gives you some options for grid lines. Most of the time you don't have to do anything with that, you can just leave it. Okay, scale, same thing, right? I mean, you can change the scale, but it really messes up the graph. I would just usually leave it. Okay, and then here it'll give you a series. That's what you do if you have more than one set of points. Okay, we don't have that on this graph, so the only thing you might want to do here, I like to do this, I like to make the points a little smaller. Then the graph doesn't look quite so busy, but that's entirely up to you. Okay, and you can change what they are. You can make them stars or whatever. Okay, it doesn't really make too much difference. Okay, if I scroll all the way to the bottom, you'll see that it says trend line. That means putting a line on your graph. Okay. In Science 10, we don't connect the dots on a graph. Okay. It's not going to make any pretty picture hidden in the dots or anything like that. Okay. We just want to get a best fit line. How many people have heard of a line of best fit or best fit line? Okay. How many of you took math already? Math 10. Okay. Then you've heard of a best fit line or a line of best fit because that's part of math. Okay. All right. So trend line here says none. I want one. So I want to click on none. Now, do these points all go in a line? Like they look like they would all go, like if I put line on there, it would almost connect the dots, right? Like they would all be in a perfectly straight line. Okay, so that's what I want to select. Okay, this isn't an exponential or a polynomial relationship. Those have curved graphs and the points don't look like a curve. Okay, so I'm going to click on linear and it's going to draw the line. Right, and you can see that some of them are kind of on it, some are a little below, some are a little bit above, and that's fine. All right, it also puts an extra thing here in the legend. Now, once I've done that, you'll see that I'm no longer at the bottom. It bumps the scroll bar up a little bit. That's because now down below, there's some other options for the line. Okay, so right now it says label, custom, and it just has trend line for data series. Okay, I don't want that. So I want to click on custom. And I want to use the equation for the line. I'm going to teach you about what that equation can get you here in a minute. Okay, but for right now, I just want to make sure that it's on my graph. Okay, so I'm going to click on use equation. All right, and you can see over here that it's now got this equation on this side. Okay, everybody with me? Caught up to me? Okay. All right, then my graph is done. Okay, that's all I've had to do. It takes way less time than having to draw it by hand, right? Which you guys have honestly probably never done. All right, so just click on update and it'll insert the graph for you and then we'll have access to it. So click on update, there's my graph. Okay. If I wanted to, now I could copy and paste it into a lab report. Okay. If my lab report needed a graph, I would just go up here, okay, and I could copy the chart, paste it over into my lab report if I needed to or whatever. Okay, everybody with me there? Okay, then let's have a look at what kind of things we need to do with this graph. Oh, that's not the right one. Okay, perfect. I will just cut it over here. Sorry guys, I just got to capture this and bring it over. Okay, so now I've got my graph. Now, what this graph shows is the relationship between, oh, and I cut diameter off, sorry, my label is actually down there. Okay, what it shows is what happens as I make the radius of a circle bigger. Okay, it says that as I make the diameter of the circle bigger, the circumference gets what? Bigger. Yeah. Okay. If the line is going up, it says that as x increases, so does y. Right? And that makes sense. I mean, if I have a circle with this diameter, it's small. If I make the diameter bigger, the circle gets bigger. Okay. All right. Now, what's the thing that relates those two? Right? Like if I want to calculate the circumference of a circle, what's the formula for that? Pi times, okay, well, it's actually 2 pi r, or it's pi times just pi times diameter, right? We're graphing diameter and circumference here. So this line, okay, should have a slope equal to pi. because that's the relationship between circumference and diameter. They're related by pi, right? I multiply my diameter by pi, and I get my circumference. Everyone okay with that idea? Okay. So slope calculations, here's how they work. All right. How many people have done slope calculations already? Okay, a few of you. All right, so this formula right here is actually this formula. Y equals m times x plus b. They just don't put the y in there anymore. They used to, but they don't anymore. All right, so 3.1 is m. It's actually 3.14. I don't know all the ones, but whatever. You know, pi goes on forever. Okay, then times x plus 0.149. Okay, so that's our what we call our y-intercept. I'm not sure why the scale went like this, but you know what? Actually, I'm just going to adjust that. Okay, so now we're back to this here, and we actually have the right graph now because obviously a circle with no diameter is a point, not a circle, and would have a circumference of 0, so we have to include that point as well. All right, so now we've got our best fit line, and it's saying that the slope is close to pi. Pi is 3.14, okay? It's 3.12, but I mean, that could be error in measurement or whatever, and no graph is perfect, okay? Well, we've got our line here. Now that, as I was saying before, this equation here is y equals m times x plus b, right? So what that equation allows us to do is calculate some things about the graph, even if they're not on the graph, right? So y is any y value. So any value on our y-axis. Same with x. X is any value on our x-axis. Okay? M is the slope. Okay? So in this case, for this graph, the slope is 3.12. Right? B is our y-intercept. That is, where does the line cross the y-axis? Okay? So in this case, it crosses it at almost exactly 0. Right? There's just a little smidgen, okay, that doesn't make it exactly 0. Everybody with me there? Okay. Now, so Google Sheets has spit this out for me, okay, this equation. And what that equation will allow me to do is to calculate things that are beyond my graph. Like, for example, it could say to me, what's the circumference of a circle with a diameter of 20 centimeters? Well, I can't read that off this graph because my graph doesn't go that far. My graph only goes to 6 centimeters. Okay, or 7 or 8 or whatever it went to. Okay, it doesn't go to 20, right? But if I wanted to calculate the circumference, circumference is on my y-axis. So I would be solving for y. Okay, they told me the diameter is 20. Well, diameter is on the x-axis, so that means x equals 20. All right, so I could take my 3.12, multiply by x, which in this case is 20, add this number, add b, and I would have the circumference of that circle. All right, that making some sense? Okay, so that's what that formula allows me to do. All right, now we can manipulate it as well to find other things. If, for example, the question said instead of find the circumference, what if it said you have a circle with a circumference of 100 centimeters? What is the radius? Okay, well then I would manipulate, or sorry, what is the diameter? Then I would manipulate for x. It's asking me to find the diameter, which is an x value. It told me the circumference is 100 centimeters, so it told me what y is. All right, how would I manipulate this formula for x? Thinking back to our rules of algebra from last week. How would I move stuff around? No, I don't want to move x. X I want to leave where it is because it's on top right now. Okay, remember our rules of algebra. If I want to move something, I do the opposite. What I do to one side, I do to the other, and I move what's not attached first. Minus b first. Okay, b is not attached to x, so I would go y minus b equals m times x. Looking for x, so what do I do with m? Divide both sides by it. All right, now I'm solving for x. Okay, so it allows me to find things that might not be on the graph using the information that is on the graph. Okay, now when you took, because I think most of you have done the graphing in Math 10 already, okay, you might have learned that slope is rise over run. Okay, how many people is that familiar to? Okay. And there's nothing wrong with that formula except that all it will calculate for you is slope. Okay? It can't be used for anything else. But this formula is the same formula. Okay? So let's say that I'm looking at my line here and I want to find slope. We said slope was m. All right? So to get m by itself, we would do very similar to what we just did. First, we would subtract b. Okay? And then I would divide by x. Okay, so now let's have a look at it. Let's say we're using this point. That would be y, and I'm subtracting b, which would be down here. So would y minus b be the rise of my line? Right? It's how high the line goes or how much the line goes up. Okay, if I do that. And if I'm dividing by x, okay, here's the x value for that y. If I divide by x, is that the run? Right? That's where that formula comes from. It's just a manipulation of y equals mx plus b. So y minus b over x will give me my slope. Okay? Sorry, I scribbled out the wrong thing here. Equals m. Okay. All right, so we're going to be using that quite a bit here over the next little bit. Okay. Now let's have you guys try. Okay, let's see if we can walk through another one here. Okay, so this one here I want you to graph, okay, and we're going to go, the length of the elastic band is going to go on the x, force on the elastic band is going to go on the y. Okay, so this is the one we want to put in column A. Okay, length is going to go in column A, okay, and force is going to go in column B. Right, so I'll let you guys work through that one here real quick and see what you come up with. Okay, see if you can build a graph just like we did here a minute ago, okay, on your own, and then I'll do the same thing in a minute. All right, so now we've got this graph of length versus force for an elastic band, and we have our equation up there that says that y equals 0.5 times x plus negative 3.25, which means the y-intercept, that is where the line crosses the y-axis, is actually a negative number, right? So it's down below 0. We can't really see that on this graph, okay, but it crosses down below the x-axis, and that's fine. That happens sometimes. Okay, so here's what I want to do. With this graph, I want to go through a couple of the kinds of questions you could get in relation to the graphing equation, okay? And that graphing equation, again, is y equals m times x plus b, okay? So with this graph, okay, our first question is going to be, whoa. Okay, so our first question will be, how long will the elastic band be when it's stretched with a force of 20 newtons? Obviously, 20 newtons is not on my graph, okay? It's past my graph. Is it a y value or an x value, the 20 newtons? Okay. Sorry, I should say cm. I must have missed that. Okay, so we're looking for how long this thing is going to be. The 20 newtons, is that a y value or an x value? It's a y value, right? It's on the y-axis, right? That's where force is. So we were told 20 newtons. So we were told, here's y. Okay, Google Sheets gave us what m is and what b is. So what am I looking for? X, right? Because the length is on the x-axis, and it's asking me to calculate how long the band will be. All right, so I need to manipulate this equation to solve for x because my givens are y, m, and b. All right, so we said first thing we want to do is subtract b over to the other side. All right, so y minus b equals m times x. I'm looking for x, so I'm going to divide both sides by m. All right, so now I'm solving for x. All I have to do now is plug in my numbers. Okay, I've already manipulated the equation. Okay, so Y, we're told, was 20 newtons. B is negative 3.25. And M is 0.5. All right, so that's going to equal X, which is going to be the length of the rubber band when it's stretched using 20 newtons. Whoop, not negative, minus negative 3.25. Okay, so we got 23.25, then we're going to divide that by 0.5. All right, so the rubber band should be 46.5 centimeters long when stretched by a force of 20 newtons. All right, I'm going to write another question up here, and I want you guys to see if you can calculate the answer to it. Okay. Okay, I'm going to give you guys a couple minutes to see if you can solve that one. So in this question here, they told me the length of the rubber band is going to be 36 centimeters. Is that an X or a Y value? It's an X value because length is on the X axis. Okay, so they told me that X is 36 centimeters. Okay, we already know that M is 0.5, and we know that B is negative 3.25. Right, so we know those numbers. All we don't have is Y. And Y equals M times X plus B. So we don't even have to manipulate. We just need to put the other numbers that we have into the equation. Okay, so M is 0.5. X is 36 centimeters. Right, and B is negative 3.25. Right, when we do that, we get 14.75 newtons. Newtons are the unit for force. Okay, so we would need 14.75 newtons in order to stretch the rubber band to a length of 36 centimeters. Okay, is that making some sense? All right, try one more here, guys. Okay, so for this one, number of sheets is going to go on the column A. It's going to be on the x-axis. Okay, thickness of the book is going to go on the y-axis because the number of sheets determines the thickness of the book. Okay, so number of sheets goes on the x, thickness of the book on the y. Okay. I'll give you guys a few minutes to get that one assembled. So, first question here. Okay, so I've got thickness on the y-axis, and I've got the number of sheets, okay, on the x-axis. So how thick is one sheet? No? You sure? You might be right. Okay, so let's just have a quick look at this equation again here, okay, when we're trying to answer this question of how thick is one sheet. 0.15 millimeters. Notice that also happens to be the slope of the graph. Okay, it's the slope of the line because, okay, this number tells us the relationship between the rise and the run of this graph. Okay, the rise is in millimeters and the run is in sheets, which means the units for the slope are millimeters per sheet. So the slope tells us it's this many millimeters for one sheet of paper. Okay, all right. So let's look at the next thing here. So according to this rule here, okay, according to this rule, we want to, let's say, find Let's see if you can answer that one first. How thick is a book with 1,038 sheets? Okay, see if you guys can calculate that one. Okay, so for this first question here, what am I looking for, y or x? Y, okay, because thickness is on the y-axis. It's asking me how thick the book will be, okay? So I'm looking for y, okay, using this formula here. So I don't have to manipulate it. It's already set up to solve for y. All I have to do are plug in the numbers. M is 0.15, okay? X is 1,038 sheets, because that's what's on the x-axis, okay? And we got to add in, okay, the y-intercept, which is probably like the thickness of the cover, right? Because it's how thick the book would be when it has no sheets, right? It still has a thickness, so I would say that's probably the thickness of the cover. All right, so I have that information there. All I have to do is punch it into the calculator. So 0.15 times 1,038, okay, plus 5. All right, so it should be 160.7 millimeters. In thickness. That's 16 centimeters. So that's a pretty thick book. It's like War and Peace, something like that. Okay. All right. Questions on that one? All right. Then try this question. Okay, find out how many sheets there would be in a book that is 95 millimeters thick. Okay, so if we're looking for how many sheets, are we looking for X or Y? X, okay? The X is number of sheets is what's on the x-axis. Okay, so we have y equals m times x plus b, and we're looking for x, so we're going to subtract b from both sides. So we got y minus b equals m times x, and then we're going to divide both sides by m. Okay, that gives us our formula for x. Now we got to plug in our numbers. Okay, they told us what y is. It's 95. Okay, we're going to subtract b, which was 5, right? Yeah. Okay, and then we're going to divide that by m, which came out to 0.15. Okay, so we're going to have 90 over 0.15. All right, so it's going to have 600 sheets. Okay, so these are calculations that you guys are going to be expected to be able to do in this course. Okay, to be able to manipulate y equals mx plus b, solve for stuff using data from a graph. Okay, so what we're going to do in the lab that we start on Wednesday, that'll be part of the analysis. All right, any questions on how that works?